Hello, everyone. My name is Joris Peels, and this is another episode of 3D Printing News Up Unpeeled, together with 3dprint.com. Today, we've got some exciting news for you, and we've got five news items overall, and that's the top additive manufacturing 3D printing news of the last couple of hours or the last days. So, number five is Toybox Labs is using NASA licensed toys to print to let kids print rockets, vehicles, and logos. So right now, Toybox has licensed vehicles and spacesuits and other things from NASA to let kids print, and to a certain extent, in some cases, customize these toys. It previously licensed from Universal and Paramount, other things including Minions and SpongeBob, and essentially the company's trying to build this ecosystem by making a quite simple 3D printer plus a software ecosystem layer that allows it to print really interesting content. It's easy to see how kids and parents will be enticed to 3D print like SpongeBob or Minions or other things that they enjoy or they like. And I love the idea that kids can like kind of, and to a certain extent, in some cases, manipulate these things and make them theirs. But so as a business strategy, this is something that really does have legs, right? On the other hand, it could be really exciting as well to let kids create exactly what they actually want to create a world that they actually want to live in and create things that are actually live in their minds. So really, truly be creative. And to me, that can be done through creation tools that really let kids express themselves. And that doesn't exist at the moment. We do have certain things that Tinkercad 310, these kind of things are floating around still. But we really don't have like a kind of like a tool besides Minecraft, right? That lets people really create. And in Minecraft, the connection between Minecraft and 3D printing is still not, solid enough to let people and easy enough to let really people create a lot of things. I think, we're on the cusp of this. And that's why I really think we should follow companies like Toybox. It just seems like an ancillary thing compared to what like larger companies are doing. But a company like if that becomes the toy of the year or the toy this Christmas or something, it could really outpace a lot of other 3D printing companies. The next bit of news is Evonik and Stratasys partner. So Evonik is a long-time material supplier to 3D printing. They dominate the powder bed fusion PA12 space. But they also have filament, they also have medical materials, and they also have, which is a bit new, a lot newer than the other things, they also have photopolymer-like materials. So now they're partnering with Stratasys for the P3 platform. That's their formerly Origin kind of open DLP platform. And they're becoming an Evonik or Stratasys material supplier. Now, first off, this is really good news for Stratasys because Stratasys just bought Covestro's AM business. And this means now that, one of the fears people had about that acquisition was, well, is Stratasys only going to focus on its own materials? And are we going to maybe miss out on materials from like Henkel or other companies? And now, yeah, with having Evonik partner with it really shows that maybe Stratasys can have its cake and eat it too, and it could still attract people to working with its OEM component, the machine building business, by supplying materials to it. So I think it's a real validation of the Stratasys strategy, and it shows us as well that Evonik is still on the move and Evonik is still committed to 3D printing and investing in it. Previously, Evonik made, together with like a Sega, they made materials for their platforms. So that's kind of what they're doing. They're doing kind of a making specific materials for specific printers and OEMs possible kind of approach. We're different than a lot of other people bringing to market now, but I think it could be a very, very valuable way to lock in a lot of value for customers and end customers. Right now, the material you see in front of you is the P3 Deflect 120 as a high heat deflection, a relatively high heat deflection material with 120C heat deflection, which should produce stronger parts. And hopefully they'll work together a little bit more in the future as well. Another company that we haven't heard from in a while and is now making its presence known is Sabic. So on the general trend of things, we're seeing a shakedown in the material suppliers, right? Every material company in the world piled in and also piled out, right? Now DSM sold, or Clariant sold its stuff to DSM, and DSM sold it to Covestro, which sold it to Stratasys, right? Now, of the largest companies like Braskem is making noise about being in this market, but a long-term company such as Arkema is also, to a certain extent, continuing, but it's probably reevaluating its steps at the moment. And then on top of that, we have companies like Sabic and Evonik that are long-held people. Sabic, of course, has been doing the Ultem PI materials, polythermite materials, for a very long time in additive. and now it's looking for new applications as well. So it's nice to hear in the same day from both Evonik and Sabic, because we were a long time unsure what Sabic was going to go do with 3D printing, and they're making a lot less noise than they used to. So this is wonderful news. So Sabic has launched and you're gonna have to bear with me here, L&P Thermocomp AMDC0041XA51, which sounds like an alien spaceship or something. But anyway, that material is a carbon fiber reinforced pellet AM material. So I love this because long term, Sabic, of course, worked long term with Stratasys for a while, focused on just FDM generally, and then kind of shifted its focus to thermwood and other large LSAM and large pellet driven processes. So pellet is, of course, cheaper for the cheaper to make because you don't have to convert a pellet again into filament. Um, and also at the same time, it's cheaper to print. It does differ your print characteristics a little bit because depends on the size of your printer. But and for some things, filament could be faster or could be more attractive. But for pellet, generally for large scale, what we at 3dprint.com we call medium format is everything to 1 meter cubed. Everything above that is large format. And especially for large format, we're seeing pellet extrusion become the standard right now. Of course, it has to be reinforced because these pellet extrusion systems are really large chambers, not heated chambers. So they have to really be resistant to warp. And the formulation, the compounding, and also this fiber material keeps it from warping. So specifically, this material has been designed for large parts and then reducing warpage. So very much what these guys need. But which I think is very exciting is that it's compliant with EN 45545 and other railway standards. So it's specifically made for rail. So where we saw Sabic previously focus on aerospace tooling as one of their biggest applications, the really biggest interest areas, now they've kind of added rail to that. I love rail. Rail is think of all the trains in the world. There's a huge volume there. They all last for a very long time. They have to be refit every couple of years. And imagine you're a rail company and you want to do something like you want to make your trains braille accessible because the new law says you have to or because you want to because it's nice. Imagine trying to add like a braille seat number or carriage numbers to everything. Right? Imagine the complexity of that. Or imagine if you wanted to make your doors a little bit safer to stop them from clogging, or if you wanted to, uh, um, make the windows easier to open, or if you want to put new body panels in. It's all going to be ridiculously expensive, ridiculously um, difficult to do, and also kind of the wrong size. One hand, you have large volumes and you have thousands of things, but you don't have the hundreds of thousands of things that'll warrant the use of a mold, right? Or, something would be wonderful, but it needs to be both lightweight and quite large as a structure. So it's really difficult to use stamping and metal components. And then, you just have this kind of Cinderella problem where you can't really find with rail a lot of the right parts at the right price for what you specifically need. So then 3D printing plays a role. Of course, there's a lot of low volume stuff as well happening with low volume MRO and repairs, which could also be really valuable. So Clariant initially also had a rail material. I think this is a fantastic market. What you need to know is, for example, there's a thing called Mobility Goes Additive, which is a whole bunch of rail-related companies. Now they do more than just rail, but they were fairly focused on industrializing 3D printing for rail because they saw the opportunity and they saw the many billions of dollars these guys spend on MRO and repair and all this other stuff. So I think this is an absolutely fantastic application for large-scale 3D printing. Absolutely fantastic material launch. And it's nice to know that Sabic is alive and kicking in our market. Somebody who's a lot more than alive and kicking is Nikon. Nikon has now announced its investment in hybrid manufacturing technologies. So Nikon was a long time seen quite aloof, just like Japan Inc., all the big Japanese companies, quite aloof to 3D printing. Now Nikon is a lot less than aloof. So a couple of years ago, they bought More 3D, a big, very specialized company in servicing or manufacturing 3D printed components, right? Now, this turned out to be a quite brilliant due diligence step because that taught them a lot about the reliability, repeatability, and how the 3D printers worked and which ones were good. The company then recently went on to buy SLM Solutions, quite a big investment, but a patient one compared to other people charging in years ago. And that gives them the second or third place in the powder bed fusion market already. Now they're investing in details are scarce. They're investing in hybrid manufacturing technology. Now, hybrid manufacturing technology is probably not super well known. They've been around since 2012. They do DED and extrusion heads, essentially. So you can make a head, like this ambit head you see in the picture, and that head can be placed in your machining station or in your kind of like whatever solution you have, motion control solution you have. They do both metal and polymers. They have hybrid, or you can drop this head into like a hybrid solution where you deposit material or clad material, or even deposit polymers they have, but usually it's metal. They deposit materials, and then usually you can even switch the head for like a subtractive head or a CNC or something like that. Or you can use different heads in combination in that custom manufacturing solution. I'm really excited by hybrid because they've been around since 2012. They haven't really built a huge name, I don't think, compared to a lot of other companies, but they've really built a huge capability. So it's kind of a quiet, kind of really capable company. And where they really shine, I think, is if you would like to make like kind of like a customized um, a manufacturing solution in DAD or extrusion of metals, right? There, they've got like the control systems, they've got the heads that you have for inspection, for example, as well, and they've got these deposition heads that you can use for cladding or for depositing material or extrusion. So that to me, if you wanted to make a custom manufacturing solution, let's say a custom platform for building, doing turbine blisk repair or mold repair, or any kind of rejuvenation repair where you're adding material to a worn down part and then cutting it away until it's new again, yeah, this would be ideal technology for it, right? Other alternatives could have been Meltio, maybe, which is a Spanish startup that does a lot of the same things. Uh, but there are very few actual alternatives to this that would be as kind of inexpensive to invest in. I mean, you could have done Shaki as well or Optimec. That would have been a bit more complicated, I think, for foreign ownership. And this gives Nikon a really great opportunity to take in not only like a leadership role in powder bed fusion, but also to have hybrid manufacturing solutions. Right now, we tend to use these technologies all in isolation, but of course, in the future, it would be much more logical to have a line where you make a powder bed fusion part and you clad it using DED, for example, and then you remove parts with CNC. So in that kind of a vision, this hybrid manufacturing technologies as a company really makes sense. Really at coding, repairing, rejuvenation, and also that custom industrialization solution. So now this gives Nikon exposure to leadership in powder bed and a role in DED. And it's becoming obvious that, well, maybe are they interested in binder jet? Or, given their own experiences in inkjet and all these other technologies, have they already worked on it and they're only going to go with their own technology? That's clear. If they were interested in binder jet, they probably should have bought digital metal a couple of weeks ago instead of the Mark IVs buying them. So it would seem clear that they're probably also going to come up with a binder jet solution as well. But generally, what we think they're doing, and what's becoming patently obvious that they're doing, is that they're developing a end-to-end manufacturing solution using the 3D printers it owns, all the quality assurance, quality control, inspection equipment that it owns, and now using multiple 3D printing technologies into one integrated manufacturing solution. Absolutely brilliant. Like Nikon is the smart money in 3D printing right now. I am so enthusiastic about what they're doing, and it's amazing what they're doing. Really, really, really amazing. Because the number one news item, and you might have missed this one, you probably heard the last one, you might have missed that one, is that Nikon invests in Optisys. And Optisys is a company making RF antennas. It's a US based company. They use SLM Solutions machines. They have one, I think, to make RF antenna components. So RF antenna, like Ku-band antenna, are antenna that are mainly used for space orbit communications, for satellites, for example. Um, the growth in satellites is going to explode several thousand%, most people predict. And the RF communication is the way to go, really. There's a lot of other uses for these Ku-band antenna as well, including systems for intercepting missiles, systems for kind of more communication, not only from just like a ground station to a satellite or a satellite to a lot of different ground stations, but also systems that communicate for individual military vehicles with other vehicles, and also with satellites, or through satellites with other vehicles. So there's a lot of military applications and emerging kind of new space economy applications that are being unlocked by Nikon in this case. Um, And Optisys has been like, there's another company called Swiss 212 that also does this using different technology. Optisys is kind of leading in this. They're US based, where a lot of the new space economy is, and also they're US based, where a lot of the defense work is invested quite heavily in these kind of communications platforms. So this is again a brilliant move by Nikon. Now they're investing in the company. Again, the details haven't been disclosed. Um, Now let's look a little bit about why RF antenna are so exciting for 3D printing. One, um, reduction of mass is always going to make sense in satellites, of course, and on these vehicles, because the smaller you have that package, the more you can do with the rest, or the faster you can make your plane, your drone, your satellite, or whatever, or the more capable you can make it. The other thing is that these Ku-band antenna have a specific shapes and specific things that make them perform higher because they are 3D printed, because we can get that specific geometry correct. Then there's another advantage, which we see is this integration, right? Integration or functional integration, where we're seeing, for example, that an antenna component is also a heat sink, or an antenna component is also a fastener, right? So we're using multiple components in a kind of an integrated way. On top of that, we have part reduction, which makes sense for everyone, but it's especially valuable in these satellite type, high weight saving kind of applications, because if you're doing a part reduction in this case, it means that you can iterate quicker. It's also easier to make your part kind of conform to whatever geometry of the package you're going to be put into. And on top of that, what's important is the assembly, right? And the assembly is going to be really, really expensive, because um, you're going to have a person, a very expensive person, in a very expensive room working on a very expensive thing. So the least amount of time she could be in there making that thing, the better, right? So we're really seeing that this kind of like part reduction, also a design for integration or design for assembly, can be really important. Also, we're looking at a lot of companies that want to integrate antenna clusters and all sorts of antenna and get lots of satellites out there, kind of automate this process. How are these guys going to make all these antenna? Right? How are these guys going to make all these components? It just isn't, the business isn't set up for that. So I think this is a fantastic move. I think it's a fantastic move by Nikon. It's a choke point in AM. It's a choke point in the space industry. There's a lot of exciting space companies out there making vehicles, launch vehicles, rockets, space vehicles, all this kind of stuff. But they've really happened on a key component that is specifically advantageous when 3D printed, and specifically important to the future of the space economy and defense. So I think Nikon is outstanding, absolutely outstanding. I don't know if there's like a corporate development award or something for 3D printing. There should be, and Nikon get it. It's patient money, and a long time it seemed like it was aloof money, but they're doing an absolutely fantastic job. Thank you so much for hanging in there today, and